Okay, good morning, all. Today we will discuss about the requirements for construction of IoT. Okay, so now if any application is asked to design, then actually what all the parameters you need to see. So those points we will be considering now. So first one is designing a communication framework for connecting devices for their LAN and provision for data gathering. That is when you start designing, you should think like how to communicate, because this is mainly based on the sending or receiving the data, okay, from one place to another place. So what are you going to do, okay, which communication platform you are going to use, okay, so that you need to think about. The second thing is, okay, designing a data enrichment, data consolidation and data transformation framework. So you would have gathered the data, so whether that data has to be sent as it is, in some of the cases it might be like that, okay, or it has to be enriched, that is enhanced, that is amplified, okay, or it can be modulated. So all those, whether is it required, if it is required, where it has to be done, okay, so that you need to design. Then data consolidation and data transformation, like whether data has to be sent in the same form or it should be consolidated, okay, aggregated, all those things you need to uh, verify. Next, designing a gateway component for connecting the devices network with the internet. So yesterday I have told you the working of gateway, like what is the purpose of gateway. So gateway can communicate between two different domains. Okay, it has the ability, it can be designed to change the protocols, okay, to transfer the data. So that gateway you need to design, okay, which components you need to take, that you need to think of. Next is designing application and application support framework for services, applications and processes. So applications or services or processes is given to you. So for that, actually what support framework you need to do, that you need to find out, that you need to decide. Got it? So these are the four steps which we need to take care for designing the IoT. Okay, that is specific for a specific application that you might be knowing by now. Okay, next we'll come to the IoT or M2M systems, layers and standardization. See, like IoT or any M2M application, when you design, you cannot do it on your own. It has to follow some regulations. Okay, so these protocols have to be standardized, so that whatever application you have developed, that can communicate with the outside world. Okay, so that is called as standardization. If you're doing it exclusively for your use, then you can customize it. Okay, that is separate. Now this is actually standardization. When you are communicating it through internet, so it has to be standard, it has to follow the standard uh, uh, procedure. So like how to design this standards. Okay, so many teams have come up, those who are working for IIT have come up with this, certain design standards. So few we will be studying here. See, first one is Internet Engineering Task Force, IETF. Okay, this is one international unit. So this initiated action for addressing and working on the recommendations for engineering specifications for the IoT. Okay, so it started working on how should be the specifications, okay, what should be the specifications for the IoT. It suggests specification for layer and the engineering aspects for the IoT communication and network and application. Okay, so uh, we have certain we have OSI model. Later we will be mapping it. So in that, whatever they are designing now, how is it relating to the OSI? Because finally my data has to transmit through the internet. So for that, it has to be compatible with the OSI layer. So, okay, based on that, keeping that in mind, specification for the layer is designed by IETF. Okay. Second one is second group which recommended the standards are International Telecommunication Union for Telecommunication (ITUT). Okay, it suggested a reference model for IoT domain. Okay, network and transport capabilities for the IoT services and the applications at application or sublayers. Okay, application layer will have a sublayer again. So in that, so this is one more thing. Same thing, it is the job of this is also same thing. What did it do? Okay, it took the reference model. Okay, it has designed or it has suggested a reference model for, okay, exclusively for IoT domain. Okay, then how it has to be networked and transport capabilities. What are the transport capabilities for the IoT services? So that is given by, okay, it's a standard, it's given by this ITUT. The third team which came up with the standards are European Telecommunication Standard Institute, ETSI. It initiated the development of a set of standards uh, for the network and devices and gateway domain for the communication between machines. It proposed a high level architecture for application and service capabilities. Okay, so this is like, see, this team has come up with the IoT as well as between machines, that is M2M. Suppose you have an application where actually M2M communication is also there, machine to machine, as well as machine to internet is cloud is also there. So then, see, actually gateway domain. What are the gateway domains for it? When IoT comes, then the gateway comes into picture. Okay, so that also it has given the specification how you should design the gateway, and it has given the communication specifications for M2M. Okay, uh, the last one is Open Geospatial Consortium, OGC. Okay, the feature of this is, see, it works with the along with the support of geographical information, web support. Okay, so any application, any IoT application is there such that it requires the geographical information of the web, then this can be used. So these are some of the standards. So it is not that, okay, all these standards are in used in your one IoT application. Okay, some of them are used in some platform. Okay, so but these are for your reference. So for the examination point of view, it may be okay asked as a short note. Next, uh, okay, it is modified OSI model for IoT. So modified OSI model, why? I told you we have a certain group which have come up with the standards. So check out here. Okay, here it is 6 layers. Instead of 7 layers OSI, you have 6 layers here. Okay, here as you know, physical data link, network, transport, session, presentation, application. But here it is some are clubbed. Okay, some does the different what you call different job. Okay, some serves the different services. First one here is physical come data link. Here actually physical and data link are two separate. Here physical come data link, but the second link is data adaption. Okay, third, fourth are same. Check out here. Fifth and sixth are clubbed. Okay, session and presentation is application support. This is what I said. Okay, here in IoT standards, we have in the application layer we have sub layers. Okay, it has the so many. It has the jobs to perform, tasks to perform. Okay, getting the connection, all those things. But that is named as application support. The last one is application. If you see here, okay, what can you recall? Okay, this is like, see, equation of the IoT framework. If you have gone through the first class, then you will come to know. It was gather plus enrich plus stream, okay, plus manage, acquire, organize, and analyze. Then it becomes IoT applications or services. So this framework, IoT framework, is incorporated in this six layers, which is also compatible with the OSI 7 layers. I hope I made this point clear, because my IoT has to, it has to perform a different task, but it has to be compatible with the existing OSI layer because it has to use the internet. So this is the like equating point. Okay, this diagram is important. Okay. Here, data communicates from device end to application end. Okay. Each layer processes the received data and creates a new data stack, which transfers it to the next layer. Yesterday we have studied that. Okay. In each layer, most of the time, the header will be appended. Okay. Okay. Then this also shows the similarity with the conceptual framework equation. This is what I said. Okay. What are the modifications you have observed here? This I have told you. Generally, new applications and services are present in the application layer, but in the modified model, application support layer uh, 5. Okay, that is the sixth layer was the application layer. So this is now fifth layer we are talking about. Uses protocols such as constrained application protocol. Okay, this is constrained application protocol. IoT applications and services commonly set them for network communication. Okay, so this was one change we have observed. The constrained application protocol at the layer is used for, this is, I'm talking about the fifth layer. Okay, fifth layer used for request response interactions between the client and the server. This is not only this, it is meant for request and response. Okay, so many other tasks also will be performed at the fifth layer. Okay, application support layer may also include processes for data managing, acquiring, organizing, and analyzing. It can be designed like that, but if you are managing the data at the data, what is that, second layer, that is a data adaption layer, then that is also fine. Okay, depends on your specification. How do you do it? Okay. The next observation what we have done is modifications are also seen at data link layer, that is L2, and physical layer. The new layers are data adaptation and physical it is not adaptation, it is adaption, and physical come data link layer. Okay. Data adaptation layer includes a gateway which enables communication between the devices, network, and the web. Okay, it can include, it is not that it has to, see, you can give the gateway design in the other layers also, but data adaptation layer is also like the easiest way, like wherever you would have to take the data without much of processing, then you can give the uh, gateway at the second layer itself. Okay, now if you see IETF, that is the first, right? What was that? International, Internet Engineering Task Force, the model for the street light example. Okay, this street light example we have seen in the first class. One example of IoT, simple example of IoT, how actually different layers works. Okay, just we have listed it here. Check it out. L1 layer. Okay, it consists of smart sensing and data link circuits, with each street light transferring the sensed, sorry, it is not data, data to L2. Okay, so L1 we know it is physical come data link layer. In the IETF model, first L1 is physical plus data link layer. So both the jobs are performed here. Okay, smart sensing plus data link. L2, it consists of group controller. Okay, see here are the group controller. It controller which receives data of each group through Bluetooth or Zigbee. Okay, aggregates and compacts the data for communication to the internet. It also controls the group street light. That is done at the second layer data adaption. L3 gives you, okay, that is network layer. That gives you, it communicates a network stream on the internet to the next layer. Okay, because the next layer is transport layer. Then in the transport layer does the device identity management, okay, identity registry and data routing to the next layer. The application support layer, this is the fifth layer where we found the changes. Application support layer does data managing, acquiring, organizing and analyzing. It also does functionalities of standard protocols such as um, constrained AP, UDP and IP. Okay, see this all is done at the application support layer, that is layer 5 for the streetlight example. It need not be same functionality for the other examples. The last application layer, because here we have only 6 layers, enables remote programming and issue of central station directions to switch on or off, okay, and commands of services to the controllers along with monitoring each group of streetlights in the whole city. This is the application layer, because the control station, okay, that is the central station which controls the whole application is at the cloud. So this application layer takes the directions from that and it distributes it to the different controller. Okay, it monitors the each group of the street light. Okay, now this is uh, see ITUT, that is the second one I said, no, International Telecommunication Union for Telecommunication reference model 1. And this is given with the, see, this is actually sorry, uh, comparison with 7 levels suggested in Cisco IoT. Okay, 7 levels is our OSI only, same thing. So for that, this is actually they have given how many 4 layers only. ITUT has given 4 layers: device layer, network. This is L1, okay, not L2. Okay, device layer, network layer, okay, then services and application support layer. In this only we get our transport layer as well as application support. Final is application layer. So here they have categorized into 4 layer, okay, which can be not can be, which is compatible with our 7 layer OSI model. So this is for this thing. Now here actually you can go through and you can list the differences whatever you have. You can make the notes and keep it ready, because if they ask what is the modified layer, okay, OSI standards or OSI layers for the IoT, then you need to mention these. Okay, you need to mention these. First one is that IETF and the second one is ITUT. So these two you need to check and you need to write the differences. Okay, so I will end the session here for today. Okay, next we will communication means. Okay, which are the, now today we studied about the OSI model. Okay, tomorrow we will be studying about the different communication aspects. Okay, how and all we can communicate, what are the means for communication, so that we will be studying it. Okay, thank you.